All right, hello, I'm Franz Pear with Skyline, and today we're going to talk about cracking crypto with CyberChef. CyberChef is a very versatile tool. It's really great because A, it's open source, B, it's web-based, and C, it's got a lot of different functionality for manipulating data live. So you don't have to install anything, you don't have to pay for anything. You can just open it up in your browser and use it to manipulate data. So what is CyberChef? Let's dive into that right now. So CyberChef is an online tool for data manipulation, like I mentioned, and you can use it to encode and decode data. You can also use it to encrypt and decrypt data, compress, decompress data, parse and extract data, calculate checksums and hashes. It's got a ton of different features. You could do all of this directly within the browser, right? So super versatile. Now, to access this tool, you can go to cyberchef.org. I know a lot of different schools, they might have web filters that will block the CyberChef website. If you're having trouble using the CyberChef website, you can also go to cyberchef.cyberskyline.com. We host our own version of CyberChef to help you get past any of those school restrictions. So that's a possibility as well if you are unable to access it from your school's network. So how to use CyberChef? I'm going to do a quick run through of it. It's really simple. So once you go to the website, what you're going to do is select the operation that you want. So let's just say we want to do some decoding. Well, I'm going to go to the operations menu over here. I'm going to go all the way down and select this from base 64 option. So that will let me decode base 64 data. Once I do that, you will see that I've got this operation inside my recipe. Now, the recipe is the list of steps that CyberChef will perform to manipulate your input data. So we have one item, one operation in our recipe, and we're going to now put in our input. So this is going to be the base 64 text that we want to decode. And once you do that, you're going to hit bake, also known as run. So it's CyberChef. So at the end of the day, you bake it, but that basically just means that you're going to execute all of the steps that you have in your recipe. So that's a very, very quick overview of CyberChef. I think it'll be a lot more interesting to actually use it and solve some challenges directly within the practice gym on the Cyber Skyline platform. But hopefully you kind of understand these basic concepts. You're going to go to the site, you're going to choose your options, the operations on the left side. That'll show up in your recipe panel in the center. You can reorder those items in your panel there in the recipe. And you can also enable and disable individual steps if you would like to play around with that. Very helpful, especially when you're looking at crypto, you want to try different things. You can toggle the different steps off and on. All right, so we're trying to use CyberChef here to break some crypto. How do we know which operations to actually use within CyberChef? I'm going to tell you it's all about pattern recognition. So there's no like secret sauce here. There's just a lot of pattern recognition and a lot of building up some expertise after trial and error. So the very first thing I recommend everyone is to identify specific markers that might indicate that a message is one particular, it has some sort of encoding or encryption. So one quick thing to notice is that if anything starts with 0x, that's typically an indication that that is some hexadecimal text. So that gives you a little bit of a hint there. If it ends in an equal sign, that could be an indication that it is a base 64 encoded message. Now, those are just two very small steps. If neither of those help you, go to the next one here, which is to identify the character set. So if anything is encoded using a specific base, that number base will have a set of finite characters that can be used in the message. And so if you've got something that has just zeros and ones, well, that's binary, right? Binary meaning two options, you got 0 and you got 1. So just a message with zeros and ones, it's probably binary. If you're seeing numbers and letters, and you're seeing all the numbers, so 0 to 9, but in terms of letters, you're only seeing letters that go from A to F, nothing further in the alphabet, then it's probably hexadecimal, especially if it doesn't appear that it's case sensitive. So if everything's all uppercase or all lowercase, that might be an indication that it's hexadecimal. And the last one I would suggest to take a look at, If you notice the message has different numbers and letters, and there are different cases, so upper and lowercase, then it might be an indication that it's base 64. That in combination with maybe it ends in an equal sign, maybe it has a plus or a slash. Those are additional characters that are also included in base 64. So keep an eye out for these different markers and character sets. Now, if that fails you, I've got a couple more things you can try out. Another thing will be to look at the formatting and spacing of the message. So if you are looking at what should be human readable text and the formatting and spacing seems very strange to you, like it doesn't look like that could be like a sentence, then that could be some indication that it might be a transposition cipher that is being used. Now, if none of that works, then now it's a little bit of trial and error. So try different types of ciphers, play around with it, see if you get any closer. A couple things to try out. So I would suggest starting with the easier ciphers, the ones that are gonna be the fastest for you to try. So substitution ciphers, looking at ROT 13 or the standard Caesar cipher. You can even try different amounts of rotation. Instead of doing ROT 13, you could do a ROT 12 or a ROT 14. Don't play around too much with using any custom settings with any of these ciphers until you run through all of the other ciphers and see if their basic settings will work. So if the ROT 13 cipher doesn't work, try the @bash cipher, try the affine cipher. There are several different substitution ciphers that you can go search online. Maybe you can even use them directly within CyberChef. Once you get through all the easy substitution ciphers, if you got other transposition ciphers and you haven't fully excluded transposition ciphers as an option, try those out. And once you've exhausted that, go to the polyalphabetic ciphers. So your railfence, your Wegener, however the French pronounce it, those ciphers, and just keep trying different options. Now, if you've finally gotten to the end and you don't think that it could be any of those ciphers or different settings within those ciphers that you are aware of, then your last option here is to consider, is this potentially a custom cipher? And that's when you go back and look at the patterns. So maybe there are other patterns that you might have missed because the patterns you're looking for are ones that match known ciphers. And you might have to go back and identify, maybe there is something here. Someone tried to roll their own crypto and I can break the cipher by identifying the pattern. You can also run through some sort of tool that will tell you the letter frequency and see if the letter frequency helps you identify what it might be. Oftentimes there are tools out there that might actually use the letter frequency to try to auto solve the challenge for you. So I know there's a tool called Quip where you can just put in your message and it will do the frequency analysis and it'll try to automatically decode the message based on the frequency analysis of the message and the frequency analysis of normal letters in the English language. So there's a lot of different things that you can try to really be an expert in cryptography. It really requires you to have really good pattern recognition and also just have a lot of experience using trial and error to learn these different ciphers and become familiar with them. So hopefully that gives you a little bit of a guide when you're looking at trying to decode messages. I'm going to show you how to actually take these suggestions and implement them in practice using CyberChef. So let's crack some crypto. All right, so I am over here in the practice environment on the Skyline platform. And the very first thing that I'm looking at here is the crypto 1 in the practice environment. And we've got some messages here. It looks like we have 5 different messages that we need to decode. And we are actually, luckily enough, we actually have a guide here that indicates to us that these are different number bases. But if we didn't know that, you could put my first suggestion to the test here and try to do the identification of different markers. So I can see here, this first one starts with a 0x, and it looks like it has as well letters that only go to F. So I've got a B, sorry, that's not a B, that's a 6. I've got an F here, I've got an E, but no other letters. And at the same time, we have numbers, 0, we got a 6, a 9, a 7. So it looks like there's no limitation on the numbers, but the letters, they only go to F. We don't have anything past an F. So this is probably an indication that this is hexadecimal. So let's actually go and try to decode this. So I'm gonna copy this. I'm gonna go to CyberChef, and I know that I'm gonna be searching for hex. So I'm gonna select from hex and then paste in the message here. And you can see that it automatically decoded that message for us. So I'll just come back in here and paste that in. So we got a first answer already. Now the second one, it ends in equal sign. It's got a combination of uppercase and lowercase letters. And there's a number in here as well. So using my second suggestion with looking at the character set that is being used, we've got letters, uppercase and lowercase letters. Sorry, we have numbers and we have upper and lowercase letters, and it seems that the case sensitivity is there, and it ends in equal sign. So this is a very, very strong indicator that this is a base 64 encoded message. So what I'm going to do is I have my old recipe over here. I'm just going to yoink it, like literally just pull it out, and I'm going to search for base 64. And we are taking a message from base 64 and we want to decode it into its raw value. I just pasted in my message here, and you can see the output is scribble. Let me zoom in a little bit more to make this a little bit easier for you all to see. Hopefully you can see that a little bit better now. And I'm going to go back and look at my next message. So this next one here, sorry, I didn't copy my answer. Got to paste my answer in there. Now this next one here is all ones and zeros. So because it's all ones and zeros, this is a pretty good giveaway. We're looking at binary. So back to CyberChef, yoinking this one out over here, clearing my input. I'm going to search for binary. From binary, and then I'm going to paste in my message, and there's our output securely. All right. Now this next one also looks like binary. So I'm just going to copy and paste it. No need to make any changes to the recipe. I'm going to put this new message in my input, but the output now does not appear to be human readable. It still appears to be encoded. And if we go back to my suggestions on trying to identify what's being used here, again, you can see it ends in equal sign. We've got uppercase and lowercase letters, and we've got numbers. So this looks like base 64 to me. So what I'm going to do is I'm going to add another step to my recipe. I'm going to search for a base 64 decode. So from base 64, and drag that in here. And what's going to happen when I do this is CyberChef is going to first take my input message, convert it from binary, and then after it does that, it will take the result and try to decode it from base 64. So if I drag that in here, oop, that didn't work. All right, we messed it up. What did I do wrong? Base, I might have copied the wrong one. Base 64, that's what we need to copy. There we go. Oh no, I copied to base 64. I need to do from base 64. All right, now we've got our output message. So when you're using CyberChef, there are a lot of different operations. Make sure you're selecting the correct one. You can see there, I accidentally selected the wrong one and I got gibberish. So it could be that you actually have the correct cipher, but you selected the wrong operation and therefore you couldn't get it. So make sure you double check your work that way. Don't make that mistake like I did. So I'm going to go back over here and paste this in. And I've completed our first challenge. So that was relatively straightforward. We could pretty much identify exactly what every single cipher was without having to guess. We actually kind of knew based on visual inspection. I'm going to go to the next challenge, crypto number 2. And you can see here, we've got a very, very short message. And there's no clear indication if there's any specific base being used here. I don't see any numbers, so that basically eliminates binary, hexadecimal, base 64. So we're out of this realm of trying to use some sort of number-based decoding. If I had a guess here, this looks like some sort of very, very simple cipher that's being used here. We don't have very many characters to work off of. So if we were trying to do some sort of frequency analysis, we wouldn't get very far because it's not enough of a data sample. So what I am going to do is take my third suggestion, which is just run through the different types of ciphers that you know and start with the easiest ones first. So I'm going to start with substitution ciphers. I'm going to pull out these two operations and I'm going to get my new input in here. And we are going to search for a substitution cipher. So if I search for substitution, CyberChef is actually nice enough to recommend me different substitution ciphers. I'm going to use a ROT13 substitution cipher. And you can see that already it's been able to decode it. So that was pretty straightforward, pretty easy. I can take the answer and paste it in here, and I've got that correct. Now, there is no real magic here behind how did we figure out it was a ROT13 cipher. We kind of just went through our process of elimination, and there might be some additional things that you can do in terms of pattern recognition when you get more talented at identifying these things. But generally speaking, it's probably easiest to just run through the very like simple ciphers and see if any of those get it. All right, so we're now on crypto number 3. And I think we're in a very similar situation. We don't have very many characters, so frequency analysis is not going to be very helpful. Again, it's just letters, so it's probably not any sort of number base. So I'm just going to copy this, paste this in CyberChef. And unfortunately, ROT13 did not automatically save this for us. So I'm going to have to go and try a different one. Let me try an affine cipher. So it'll do an affine decode. That doesn't look like it did it. Let's try a different one. Let's try @bash. And you can see here that this is now human readable. This is now English. So I can come in here and paste in my answer. Just like that. Let's move on to the next one. Crypto number 4. All right, so this is a pattern recognition example. Very, very clearly, you can see that we've got dots, dashes, and some slashes. So just with that alone, you can probably go and search online. If you don't know off the bat what this probably is, you can use that to narrow down the possible ciphers that are that you might have here. This actually is a encoding. So this is Morse code. Morse code is the dots and the dashes. So we can just copy this and paste it into CyberChef. And let's go look for a Morse code decoder. So from Morse code, drag that right into there. And you can see the secret of getting ahead. So this is now English. And I can just copy and paste this right in here. Perfect. All right, we're almost at the end of our crypto challenges. So crypto number 5, let's take a look here. What I can see here is that there's something funky going on with the spacing and the syntax. So if you haven't noticed already, I'm going to zoom in a little bit more. If you look in these two messages, this second message, there's actually 2 spaces between the N. Now it's possible that there were 2 spaces back to back in the message when they were before it was being encrypted. But what might also be happening is that the position of the characters are being shifted around. It's being jumbled around, which means that this could potentially be a transposition cipher. Another way, another kind of like giveaway here is that when you look at the characters, there appear to be like uppercase characters in the middle of words, as well as this like dash here. So it doesn't look like there's like a one-to-one in place conversion of each character in the message to another character. It looks like maybe the characters might have been converted, but also something probably was shifted here. So that's an indication that this might be a transposition cipher. Another hint that we have in the prompt, it says there are handwritten notes that indicated the keys as being 3 and 5. So that will also narrow down the possibilities of what we'd be looking at to different types of ciphers that would take in some sort of key as some sort of input as a key here. So I am going to take this first message and go back to CyberChef. And it's definitely not Morse code, so that doesn't work. I'm going to try a rail fence cipher. So the rail fence cipher specifically will shift the position of the characters. If you're not familiar with all these different ciphers that I'm just going and pulling, it's not out of thin air. I've spent some time going on Wikipedia and researching different types of ciphers. So if all of these ciphers that I've shown you, they're not familiar to you, go online and just search for common substitution ciphers, common transposition ciphers, common polyalphabetic ciphers. Use those, as well as look at the different ciphers that CyberChef has just by default. There are likely some ciphers out there that CyberChef does not have, but CyberChef does have quite a few, so that's a good starting point. So we have our rail fence operation loaded in the recipe, and we can see here key is 2. Now the prompt said there's a key and the key is 3. So let's actually just go and change the key to 3. And you can see that we've got our message here, and let's just copy and paste that and get our points. All right, we've got the next one here. I'm gonna paste that in, and I am going to use a key of 5 this time because it doesn't look like the key of 3 did it. Let's try the key of 5. And we have our decoded message. Cool. Let's go on to our final challenge for today. All right, looking at this, it doesn't look like any number bases. This looks like it probably is an English sentence. It starts with a capital letter. There's a comma in the middle, and like these weird, this like flag format is at the very end. This probably means that however it was encrypted, it kept each individual letter in the same place. It didn't move it. So it probably is not a transposition cipher. So let's try our usual culprits. So I'm going to get back our ROT13 cipher. We're going to get back our @bash cipher. We're going to get back our, what was it? The affine cipher. We're going to pull out the rail fence, and we're going to try one of these at a time. Okay, so ROT13, that didn't help. You can enable and disable each of these steps by using this, the not sign. That'll enable or disable individual steps. So ROT13 doesn't help. If we go to @bash, that doesn't appear to help either. Affine does absolutely nothing. So I'm just gonna pull that out. That doesn't seem helpful. I can keep going through, but I don't want to waste all of your everyone's time just waiting for me to go through all of the possible options we have. I happen to know that because there's a key here, so actually I should have taken my own advice and looked at the whole prompt and actually like do some pattern recognition. So we should be looking at ciphers that are going to use a key. @bash cipher doesn't use a key. The ROT cipher doesn't use a key. So what we need to do is find something with a key. The Vengineer cipher I know uses a key, but I don't want the encode. I actually want the decode. And I can paste the key in there, and I've solved my challenge. So hopefully you all found that helpful. Definitely get some additional practice going through the different challenges. There is a lot to learn about pattern recognition and just being familiar with the different ciphers. So if you're going through our different practice challenges, definitely would recommend searching online for different ciphers and possibilities there and just getting more practice. That's the best way for you to learn and develop your skills.